Hello friends, so our today's question of the day is combination sum second. So what is given in this question is we are given a collection of candidate number candidates. Okay, so we are given a collection of candidate numbers, okay, which is stored in a variable called candidates, okay, and a target number which is stored in a target variable. Okay, what we have to do, we have to find all unique combinations in candidates where the candidate number sums to target. Okay, so what basically we are given an array of integer number candidates, and we are given our integer number called target. Okay, so what we have to do is we have to find all unique combinations, okay, all unique combinations pair from candidates this array that will sum up into this target. Okay, now, what is given? Each number in candidates may only be used one in the combination. Okay, so if like each number in this array candidates can be used only one time. Okay, it cannot be used multiple time to form or to add up to this target. Okay, and note is given, the solution set must not contain duplicate combinations. Okay, so like 116 is there, so it should not again contain 116, it should contain the unique combinations. Okay, so like in this case, let's say we have candidates, okay, 10 1 2 7 6 1 5, and target is 8. Okay, so what first pair which is formed is 1 1 and 6. Okay, as we are having 2 1, so each element is used only one in the combination. So this one is used one time, this one is used one time, and this 6. Okay, so it forms into 8. Then 1 2 5, in the same way 1 7, and then 2 6. Okay, so these are the pair from this candidates array that are that sum up into target 8. Okay, so like this we have to form the pair, and we have to return this array of array. Okay, so now let's take the second example. Okay, so what is basically, we are given a candidates, okay, and we are given a target. Okay, we have to find pairs from these candidates that sum up into target. Now one thing to notice here is, here each pair is sorted. 1 1 6 1 2 5 1 7 2 6. Okay, each pair is sorted in itself. Okay, so one thing which is indicated from here, that first we have to sort this candidate array. Okay, so let's sort this 2 1. Okay, 3 times 2 2 1 2 2, and then 5. Okay, so this is our new candidates, okay, array. So we have sorted this. Now what we are like, we are basically having like, okay, so what we basically approach we will use here is like recursion and backtracking. Okay, what recursion is like, in recursion we have to form uh, in recursion we have to find the we have to just made it for the first instance. Okay, like what here we are like, okay, we are going from one, so either we will take this, okay, or we will not include this. Okay, in the same way we will go with two, we will include this or either not include this. Okay, so this is the pair, like it will form a T like kind of structure. Let's us describe this. Okay, so this is what basically we are starting with. Okay, so initially, like we are having the 0 index, and what is the target? Our target is 5, and we are having an empty pair. Okay, so this initially we are starting with. Now what is the condition? Like first index element, we will either take it or we will not take it. So if I take the first index element, okay, so what now, we will remove it from there. So what remains is 1 minus 5 minus 1 is 4. Okay, and what will be included is 1. This is index. Okay, so now this is 1. Okay, now to this we can take the second index element. So second index we have got, and what is the value here is 2, so 4 minus 2 is 2. Okay, and then what we will add in our pair is 1, and second element will be added. Okay, so this goes now to 1 we will take, either we can take, okay, let's index them as 0 1 2, or we can have them in like for now 1 2 3 4 and 5, let's consider index to be there. Okay, now so what we are having now, 2. Now third index element, either we will take it or we will not take it, as it is okay. So third index element, okay, so third index element is what, 2. Okay, so we will take, so it will subtract, so it will be 0, and what will be the pair will be 1, then 2, then 2. Okay, as soon as our target becomes 0, what we will do, we will return. Okay, we will return. So this third index now it will be compared with fourth index. Okay, so what will be the scenario here is fourth index. Okay, and what is the element here is 2. Okay, that will be what is the target here is 2. Okay, so it will, target will become 0, and this pair will come 1, 2 and 2. Okay, so this is the duplicate pair. Okay, so we will not add this in our resultant array. Now so we will return from here, so it will jump into this step, so it will go like one index, so it will check for the fifth index. Okay, so fifth will be now fifth, what currently our target is 4 and our value is 5. Okay, so we will not include this, so we will return from here and we will jump into here, so it is 0. So if we won't take first index, okay, now we will start from 2. Okay, now that's now 2, what is the so it remains is 3, and what will be the value here will be 2. Okay, now again for the 2 we will go into the third index. Okay, third index is again 2. Okay, so third index what remains here is 1, it will remain as 1 and it will be 2, 2. Okay, now as okay, now what we will do, we will take the fourth index element, and that is 2. So when the index element, like current element, is greater than our target value, remaining target value, then we will return, because we know that our array is already in sorted order and we will not be finding a smaller element than this after the current element. Okay, so we will return. Okay, so 3, so like in the same way we will 3 we will return, then for 3 we will go for fourth index. Okay, same scenario, then 5 index. So here what we are doing, basically what we are doing is either we are taking the element or we are excluding it. Okay, if we are taking that element, so from the next index we are checking for another element until we reach this target. Okay, and if we don't reach the target, okay, or rather target, if target becomes 0, okay, if target becomes 0, so what we will do, we have like in this case our target becomes 0, so we have found a pair. Okay, so we will add this in our result. Okay, result array. Okay, and if the target does not means, then we will return, we will backtrack. Okay, so this is the basically concept for implementing this whole solution. Now let's quickly implement this so it will be more clear to us. Okay, okay, so now to code this, first of all what we are doing, we are sorting our array. Okay, so we will do the same, we will sort our array, so that will be like, okay, candidates, let me copy this, candidates dot begin begin and candidates dot end. Okay, so we have sorted. Now what we will do, we will make a vector of vector to store our result, because we have to return a vector of vector that will contain our answers. Okay, so let's say result result, and we have to return this. Now vector, we will make another vector to store our current pair. Okay, so this is our result. Okay, now what we will do, we will make a function, recursive function. Okay, so let's say candidates. Okay, we will make a recursive function. Then after this call, what we will do, once the recursion is over, we will return our result, whatever the result we have. Now what we will do in recursion, so what we are doing here is we are starting from indexes, and then when we are gradually including that index, or either including or either excluding that index. So we have started with 0, we have gone to 1, then from 1 to 2, then 2 to 3. So if we are backtracking from any pair, we are we are again starting from another index. Okay, so first of all we will pass, initially we will pass 0 index. Okay, then what we will pass target. Okay, then what we will pass candidate. Okay, candidates we will pass, then we will pass our result, we will pass our pair, then we will pass our result. Okay, so this, okay, now this is a function. Now we have to define this recursive function. So find candidates. Okay, it will be a void, it will not return anything, so it will be void find candidates. Okay, now what, first of all we have to accept the parameters. So let's say I index, okay, then int target, then int candidates, then int pair. Okay, oh sorry, these will be vector of int vector of int. This will also be vector of int, and last will be vector of vector of vector of int, and that will be our result. Okay, result, oh sorry, result, and we'll pass a reference of these things. Okay, these, okay, so okay, so now we have all our parameters in hand. Now what will be the termination condition for every recursive? In recursion, what we have termination condition. Okay, okay, and then main logic. Okay, and then recursive call. Okay, like our recursive function mainly consists of these three things: termination condition, main logic, and then recursive call. Okay, so what a termination condition is, what we had found, if our if our target value becomes 0, because as we are taking any element, like if we have taken this one, what we are doing, we are subtracting it from target. So when our target element becomes 0, then we have found out a pair. Okay, so that pair we will add and we will return. Okay, so if target is equals to 0, if target becomes 0, then what we will do, we will into result we will add uh, push, we will push back our pair. Okay, and we will return. Okay, else. Okay, now what, okay, so if this is not the case, then we have to start iterating, like, okay, we have to start iterating from the index, from current index which we have got to up to the size of the array. Okay, and then we will recursively call for each index. Okay, okay, so we will, what we will do, we will iterate. Okay, so for int I is equals to ind int indexes. Okay, I is less than candidate dot size. Okay, I plus plus. Okay, so what we will do, first of all what we will check here is, like, okay, if these two elements are same, then we have to continue, because it is already on each number in candidate may only be used one in the combination. So what we will do, we will check if our int oh sorry, I is greater than index, okay, whatever the index which is passed to us, and okay, candidate of I is equals to candidates of I minus 1, like two elements are same, then what we will do in that case, we will continue, we don't have to take that element. Okay, so we will continue. Now if, okay, now one more case, if current candidate value I is already greater than target. Okay, in that case what we will do, we will break. Okay, because we know, we know that we cannot move ahead because our array is already in sorted order. Okay, if these two conditions are not there, what we will do, either we will take it or we will not take it. So okay, what we will do, we will push that into our pair. Okay, pair dot push back candidates of I. Okay, we will push back, and then we will make a recursive call. Okay, so that will be find candidates, again we will call. Okay, through what index, like I plus 1. Okay, because okay, because we are here, okay, one index, then we are going to second index. So what we will do, we will here again call it by using I plus 1. Okay, then we will what we will do, we will target, we will subtract current value of candidates. Okay, we will subtract it. Okay, then okay, another is we have to find the candidates, pass the candidates, then pair we will pass, then result result we will pass. Okay, so either this is the condition where we will include, or if this fails then we have to remove it, we will not include, so we will do the pop back. Okay, now this is our, I think this our solution is prepared, so now let's run this and check. So it is accepted. Now let's submit. So it is submitted successfully. Now to the time complexity, space complexity, as we are using the recursive call, so it may, in the worst case scenario, it may go to 2 to the power n, so its time complexity is 2 to the power n. Okay, and its space complexity is capital O of n. Okay, as we are using extra space. So thank you for watching. If you like the video, please subscribe to our channel. Thank you.